right, so let's go on page 91 when we're done. So yesterday we looked at arc length, and today we're going to look at the area of a sector. So arc length is part of the circumference. Sector area is part of the area, just like it sounds. Okay. Now what a sector is something that maybe you haven't seen before. I don't know that we have talked about it before, but let's just talk about what a sector is. So a sector of a circle is a region bounded by two radii of the circle and their intercepted arc. So it's the colored in part of that circle right there. It's like a piece of pizza or a piece of pie, right? It's a sector, like a section. It's a little sector of the circle there. And you name the sector kind of like you would name the central angle, but you use the word sector because there's no symbol for it. We're not going to draw a little sector or anything. So sector ACB, and you name it like you would the central angle. Okay. So the sector doesn't have a measure as far as degrees are concerned. It is related to this arc, and that arc has a measure, and that central angle has a measure, but the sector itself doesn't directly have a measure. It has an actual area. Okay. So just like before, the measure of this arc, AB, which is our intercepted arc, is the same as the measure of the central angle. Now, as my circle gets bigger or smaller, is my piece of pizza going to get bigger and smaller? Yes. Does the measure of this arc change? No. The arc measure does not. The arc length would, but the arc measure does not, because that's a part of the 360, right? The actual area of that piece of pizza or that sector is a piece of the area, and that's why it's going to change depending on how much the radius changes. So again, I have the same sort of little proportion. The measure is out of the 360, but the area of the sector, so capital A and then a little subscript, we're going to use SEC for sector, because when we talk about the different areas, area A, capital A means area, but you got to know the area of what, because we're going to be doing a lot of different things in the same problem sometimes, so you got to be able to identify them. So you could write out the whole word, or SEC is fine. Over, the area of the sector is a part of what? The total area of the circle, which is pi r squared. Okay. So it's a proportional relationship, almost identical to yesterday's, except instead of length over circumference, it's area over area. Easy enough? Okay, so again, there is a formula. We're going to write it up here. So the formula, which you would see in the textbook, and actually when I looked in the textbook for something else, I think they show you both now. I guess the old textbook didn't, but still this is technically the formula that you might see on a formula chart. But the area of the sector is equal to pi r squared times the measure of the arc over 360, which is really, it's not that the formula doesn't make any sense or that it's confusing necessarily, because really, doesn't this just give you what fraction of the circle we're talking about? So that's the fraction of the area. So the formula totally makes sense. Plus, the formula comes from this proportion. If I set up this proportion and then I solve for the area, so I multiply both sides by pi r squared, that's where it comes from. So that's kind of how it's created anyway. But again, using this is way more helpful when you are looking for, let's say I'm looking for the measure of the arc. I'd have to substitute in everything else and then undo that with some algebra, which isn't the end of the world and you're totally capable of. But wouldn't it be easier to make this your unknown and just change how you solve the proportion? It's just easier. If you can make it a proportion, make it a proportion. So once again, my opinion is that this is yuck, and you should use this. And that's this. I'm going to always use the proportion. You're way more likely to set it up right and remember it correctly if you use the proportion. But I'm fine if you're a formula person and that's how you want to do it. I don't care. Alrighty, so now we're going to find the area of each sector, but I'm going to change this one. I decided I wanted a different number here after I did this. We're going to change this 3 inches to 2 inches. So just change the 3 to a 2. That way our work comes out a little bit different. And we're going to start by writing down formula. Measure over 360 is equal to the area of the sector over pi r squared. So in order to find the area of the sector, I have to know the arc measure. Do I know it? Yes, it's 80. They gave it to me. And I have to have the area of the circle. So I'm going to come over here to represent area of a circle. Area, the little subscript, is going to be the little circle symbol. So it's like a circle with a dot in it, so it doesn't look like an O or a 0. Area of a circle is pi r squared. And so that's going to be pi times 2 squared, which is 4 pi. So 4 pi goes here, the 80 goes here, and then we can substitute things in. So I'm going to get 80 over 360 equals the area of the sector over 4 pi. So remember, it's going to make your life easier if you do very minimal reducing right here. Okay? What's the easy, what should I do? Knock out the zeros. Now, somebody did ask me yesterday, so every time they both end in a 0, you can just cross them out? Yes. So remember, it's not any like magic crossing out thing, because if they were both 5s, could I knock out the 5s? No. Technically, what we're doing is dividing both by what? 10. So it's just a matter of, and if there were 2 zeros at the end of both, I could do that. You're not always going to be able to knock out zeros, but I could here. Even though I could reduce that left-hand fraction more, I'm not going to. Because if I cross multiply right now, I can say that the area of the sector is equal to 8 times 4 pi divided by 36. Now, I also had some questions yesterday. I think it was after this class period, so I figured there was probably somebody in here thinking that too. Like, where the heck did I get all this from? Like, how did I come from here to here? Are you all with me on cross-multiplying there? Because I could write it out and say, I'm going to do the 8 times 4 pi and set that equal to the area of the sector times 36. But then I just divide both sides by 36, and that's where I got there. I'm just skipping that step, right? It's just how you can cross-multiply. It's how you probably cross-multiplied before you started throwing variables and stuff in there. You would just cross-multiply, multiply by the 2 that you have and divide by the third one. But that's why it works. It's because you're multiplying, technically, you're not even, if I multiply to get rid of the denominator, multiply both sides by 4 pi, multiply both sides by 36, I get here, and then I'm just dividing by 36. You want to be a little careful with just doing this and not this step if you have more than one term. Like if you've got parentheses and stuff, you might want to write out this step so that you don't get lost and do weird things. But when you only have one term in each part of the fraction, it's fine to just do this. Yes? Yeah, so that's why I said you can, but it's going to be way easier if you don't. So you can, because we're not done. And if you just knock out the zeros, once you multiply it like this is what I was trying to get across to you yesterday, is y'all usually do things the hard way. Okay, and there's also no reason to just go ahead and multiply the 8 times 4. I could, it's 32. We all know that, right? It's not like that's that hard. But when I multiply, then I'm just about to reduce again. So yeah, I could have reduced this, but I can also reduce this, right? And if you start with the smaller number, you're more likely to be able to actually reduce everything out. So does 4 divide into 36? Yes. Goes into there once and goes into here how many times? 9 times, right? So that means then on the numerator, I'm just left with 8 pi over 9. And I only reduced once and I didn't have to actually multiply anything. And I know these numbers are kind of small and simple, but when the numbers get bigger and weirder, that's going to be way more helpful to you. Okay, we all good with that? All right, so that's as much as I can reduce that one, right? And what would my units look like on this? Inches squared because it's area. And then as a decimal, so in my calculator, I would do 8 times the pi button divided by 9. I'm just going to give it to you because I didn't want you trying to do all this in your calculator. 2.793 inches squared. Both of those are your answers because it says give it in terms of pi and to the nearest thousandth. So I want to make sure that I've labeled my answer, and so I did over here, but then I have all this mess in here, so you can also put it at the end. That is the area of the sector, and then bam, that's everything. Okay. We all good? Any questions? All right. So down here, let's write our formula. Measure over 360 is equal to the area of the sector over pi r squared. Okay. So I'm going to give you a minute. I want you to completely work this one to the exact answer. I don't expect you to get the decimal, but go ahead and work this one out. Okay, so once I get here and I can knock out those zeros, again, could I reduce this? Yes, and there's nothing wrong with doing it. I'm not saying don't do it. You can. It just might be easier not to. So if I don't reduce it anymore, that's going to give me 12 times 36 pi over 36. So what can I do here? Cross out the 36s. And see, there's a whole lot less thinking and multiplying, even with the easy stuff. The easy stuff is where you make the majority of your mistakes. Don't ever forget that. Don't ever forget that. That's equal to 12 pi what? Centimeters squared. Okay, so your decimal answer should be about what number? 36? Would it be more or less? More, okay, because it's about 3. It should be around 36, 36-ish. I can't even talk. So that gives me, I get 37.699. Now, we were thinking about 36. Does that seem reasonable? Yes, because it's more than 36, right? And the larger the number you get, the farther away it is going to be from that. So that is good. That is centimeters squared, and that is the area of my sector. We all good? Any questions? Awesome. Alrighty. So, a circular plot with a 72-foot diameter is watered by a spray irrigation system. What is the area that is watered as the sprinkler rotates through an angle of 50 degrees? So we have a circular plot of land. We have a diameter of 72 feet. Okay. It's watered by a spray irrigation system. What is the area that is watered as the sprinkler rotates through an angle of 50 degrees? Well, if it's going to rotate through here, right? This is going to be my 50 degrees. Isn't all of this going to get watered here? Okay. So basically, I'm looking for the area of that sector. Okay. All right. So I need to find the measure over 360 is equal to the area of the sector over pi r squared. Okay. So I've got to go and find the area of the circle. That's going to be pi r squared, which is pi times what? 72 squared? 36 squared, because r is 36. Right? So 36 squared, anybody just know what that is? No. What is it? Okay. Could you give me like a range of numbers? What do you know it has to be less than? Give me something. Okay. Is it easier to square something like 40 than it is 36? What's 40 squared? 1600. Okay. 40 squared is 1600, right? What's 30 squared? 900. So doesn't your answer have to be somewhere between 900 and 1600? Right? So even if you don't know what it is, like that's not enough to answer the question. But those types of things that you can think about quickly can help you narrow down answer choices and help you understand if you did get something outrageous because you thought you knew the answer that, wait, that doesn't even fit in the range of answers that would make any sense, right? And do you think because it's 36, is it going to be a little bit closer to 900 or 1600? 1600. And the closer that this gets to 40, then the closer your number gets to 1600. Does that make sense to you? Okay, so I'm just going to give it to you. It's 1296 pi. And also, let's just think in terms of like multiple choice answers. This wouldn't be our final answer anyway, but if I'm going to square this, doesn't your last digit have to be 6? Right, think about that. Just think about if you're going to do multiplication, 36 times 36. So 6 times 6 is 36. And then when you go, the next time you put a 0 there, so that last digit is whatever the last digit is of that squared. Does that make sense to you? So again, that helps you narrow down some things sometimes, especially if you're running out of time or you have no clue what the answer is and you're trying to make an educated guess. There's ways to narrow down just by knowing pieces of what's going on. Yes, so like 44 squared, what does the last digit of that have to be? 6. 44 squared, 4 squared is 16. So the last digit of 16 is 6, so the last digit of this has to be 6. Does that make sense to you? Okay, so 32 squared, what's the last digit of whatever 32 squared is? 4. Okay, So when you go to learn your perfect squares, which you should already know up to 25, but most of you do not, but I did put them in the Quizlet thing that most of you have not signed up for. But as you're trying to remember those, and you've got like 17 squared and 18 squared and things like that that seem a little obscure to you, 17 squared, what does it have to end in? 9. 18 squared, what does it have to end in? 4, right? So as you have, because there's a limited amount of numbers, like you can recognize them as perfect squares, but if I tell you 289 is a perfect square, what's the square root of that? Well, does 18 make any sense? Because 18, the end of that would have to be 4. Does 17 make sense for 289? Because what 17 squared have to end in? 9. Okay, does that make sense? You see how when you start learning them, find a way to make it like as a concept, make a little bit more sense to you so they're not just random numbers. Okay, totally off topic, sort of. It's still math, and it's still how you deal with numbers. But things you want to think about, and that makes it different than just straight up memorizing what seems to be random to you. All right, so this is the area of my circle. So I'm going to go and substitute my stuff in here. The measure of the arc, I know that's 50. So 50 over 360 equals the area of the sector over pi r squared. Oh, why am I writing that again? Okay. 1296 pi. There we go. Okay, we're all good with that? All right, so then let's see. I'm going to cross multiply, and I'm going to get the area of the sector is equal to, I can cancel those out, right? So it's going to give me 5 times 1296 pi over 36. All right. Well, I know 5 and 36 are not going to cancel. These are both even, so I could start using 2's, right? But do you know any other factors of 1296? 36. Isn't this actually 5 times 36 times 36 pi? Yep, over 36. And if you learn to recognize stuff like that, instead of just jumping in and doing as much math as you possibly can, which always complicates your life, bam, those cancel out. All you're really doing is 5 times 36. Okay, so what's 5 times 30? 150. What's 5 times 6? 30. So 150 and 30 is 180. Okay, so the area of my sector is 180 pi, what are my units? Feet squared. Okay, we all good with that? Pay attention to what's happening, because the way you make your life way more difficult is that some of y'all would have gone ahead and multiplied 5 times 1296. Well, that's making your life difficult too, because 5 isn't going to divide out anyway. You're splitting them up to look at the factors to knock things out easily. You can still get the right answer. It's going to take you longer, and there's way more room for error because you're trying to rush through it because it is easy and you can do that stuff, but that's when really mistakes happen. Okay, so the decimal, I'm just going to give it to you. It is 565.487 feet squared, and so I have that labeled as the area of the sector. Did they say find the area of the sector? No, they said what area is watered. So this is the area watered. It's fine that this is still part of it, but you got to make sure you actually label it correctly. Okay, we all good? Any questions? All right, so then it says, what is the area watered in example 2a as the sprinkler rotates through a semicircle? So same sprinkler, same area of the circle and everything. What changes? The measure of the, it's going more. So we know our answer should be more because it's a bigger angle. And so all that's really changing is the measure of the arc. So what's the measure of the arc? 180. So this is 180, and that's equal to the area of the sector that I'm looking for over the whole thing, which is 1296 pi. Okay. So I'm going to cancel those out. And then the area of the sector is equal to 18 times, isn't this just like 36 times 36 pi? Right? I guess. All over 36. Right? So then cancel those out. Now I'm just doing 18 times 36. Right? Okay, well that kind of stinks, right? So let's think about maybe there was a better way we could have canceled things out. maybe instead of that, maybe I have area of the sector is equal to, and you can multiply 18 times 36, that's fine. 18 times 36 times 36 pi over 36, right? Well, here's the thing. 18 times 36 is going to take me some work, which we're capable of, but also capable of completely messing up, right? We already know what 36 times 36 is, yes? All right? So maybe instead of trying to knock out a whole 36, which seems really, really nice, maybe instead we reduce here. 18 goes into 18 once, it goes into 36 how many times? Twice. So you really get that 1296 pi over 2. Is it easier to divide this by 2 or multiply those two numbers? Divide that by 2, right? And let's think about this. Did we kind of know from the beginning that's all we really had to do? If this is the total area that's being watered and it's going to rotate through the semicircle, isn't that half the circle? So isn't it just half the area? Same thing, right? See, if you think about the whole picture and like what is happening instead of just randomly doing stuff, you can really simplify it, okay? So half of 1296, well, what is that? 648. So the area watered again, area watered is 648 pi. See, math is beautiful. And that is feet squared. And then I'll just give you the decimal. See, I'd rather spend time explaining those things to you than letting you punch around on the calculator. It's not even, I know you can punch on the calculator. That's part of the problem. 0.752 feet squared. And you know what? These things I'm showing you, you're never going to be able to do on your own if you never practice them. Practice them. I know you got a calculator in your pocket most of the time. Check yourself. There's nothing wrong with checking yourself, but try to do it using your actual brain, okay? We good? Okay. Any questions? All right. So, now we've talked about the area of a sector, which is the whole piece of pizza. So now this thing that's shaded over here, this is called a segment, okay? It is completely different from a line segment, but that's why we call a line segment a line segment. Now we get lazy a lot of times and just call it a segment, but there's a line segment and a segment of a circle, and they are two completely different things. So that's why there's that qualifier on it, that it's not just a segment. It's a line segment or a segment of a circle. It's kind of like the crust on the pizza, but really if you're going to eat the pizza up to the crust, it's most likely curved where you ate it up to. This is more like if you're just going to slice it off with a straight line, okay? So this right here is your arc. This is your central angle that's related to the arc, and then this is the chord that's related to it. So when you draw in that chord, it's this part that you're blocking off, and you have this right here, which, what is this thing? A triangle, okay? So a segment of a circle is a region bounded by an arc and its chord. This shaded region is the segment, so it's everything but the triangle. So this is going to be kind of the first time that we do what I call our kindergarten equations, and basically by little pictures or by words. All right, because it's your plan, okay? We're going to get into a lot of complex area stuff, all the pieces you can do, but we're going to have to add this and subtract this and whatever, and you've got to make a plan before you start. Because if you can make the plan before you start, you can do all the pieces, and then when you're done, you already told yourself at the beginning what to do with it, right? So to find the area of the segment, that's what this is right here. So let's write this. This is the area of the segment. Area of segment. Basically, we are translating our picture equation into words here. Equals, what's the word we usually use for equals in math? Is, yeah. There's a few different things, but is me, if you're saying a sentence and you say the word is, most likely you can put an equal sign there and make a little equation of some sort, okay, if you're talking about math stuff, okay? So this right here, oops, represents the area of the sector. And then, because I can find that, and I also know how to find this orange part, which is the area of the triangle. And so to get the area of the segment, we just subtract the two. So there's not really like a formula for it. You do the two things you know how to do, and then you just subtract them. Make sure you subtract in the right order, which might seem like a really obvious thing to do, but not when it's in exact form. When it's in exact form, you can't always look at it and just know which one's bigger. Okay, so that's one reason why you want the plan. If I tell you one's 5 and one's 7, clearly you know which way to subtract. But if I tell you one is 5 pi and the other is 7 square root of 2, you might not be real sure, which one's actually bigger, because sometimes it's not the one you think it is. Okay, so we're going to make our little plans here. So let's look at this. It says, find the area of this segment. So we're looking for this little area here. So we're going to write down our plan, and I'm going to do little pictures. I don't always do pictures. You can, if you're too cool to draw the little picture, you can write a word. It doesn't matter, but I am going to be looking for a plan. So what I'm doing is I'm going to find the area of the sector and the area of the triangle, and I'm going to subtract them. So this is my plan from the beginning. So now I just go forth and I do those two things and not worry about anything else. I know how to find the area of the sector, right? In order to find the area of the sector, I first have to have the area of the circle, right? That's a sector, yes. It's like my weird-looking piece of pizza. You can write sector if you want to, yes. So area of a circle is equal to pi times r squared. What's the radius here? 12. Okay. So the area of the circle is, what's 12 squared? 144. So this is 144 pi. Okay, so I need that, right? Then I'm going to do my area of my sector. So I need the measure of the arc. Do you know what it is? 60. So 60 over 360 is equal to the area of the sector over 144 pi. Okay. I'm going to knock these out. Then that's going to give me that the area of the sector is equal to 6 times 144 pi over 36. Okay. So remember, if you can, you'd like to get rid of the smaller one in the numerator first so that you might not have to multiply anything, but not always the case like we saw with the 18. But can I reduce this here? Yes, so this would be 1 and this would be 6, which we could have done back here, but sometimes doing it at that point isn't the best one to do. And so then if you start to get confused with all the stuff you have marked out, there's nothing wrong with just rewriting it and saying, okay, that is 144 pi over 6, so you can see what you have in case you get lost in your work there. Now, these are both even, right? So I can divide them both by 2, and so that's going to give me 3 and what? 72. Okay. All right. Well, is 72 divisible by 3? Yes. Okay. So what does that give me? 24. Okay. So the area of my sector is equal to 24 pi. Right. And I'm not even worried about the units right now because we're not done with it because we still need the triangle. Everybody good? All right, so there's the area of my sector. Area of a triangle. We know how to find the area of a triangle, right? So what's my formula for the area of a triangle? Good. 1/2 base times height. All right, so do you know the base of the triangle? Yes. Do you know the height of the triangle? No. Okay. So let's see. What do we know about this triangle? Okay, equilateral and equiangular. How do you know that? Okay, just because you have a 60-degree angle does not mean it's an equilateral triangle. Okay, so the radius, so this is congruent to this, right? So for sure, any triangle we get like this is what kind of triangle? Isosceles. You are guaranteed that it is isosceles, right? Because these two are congruent, which means these two angles here are congruent. Since this is 60 and these two are congruent, it does end up being an equilateral, but do not think just because you see a 60-degree angle, because I could put it in another spot and that may not be the case. Okay, so just be careful with that. It is equilateral and equiangular, but I have a feeling some of you that were thinking that you kind of got lucky on that just because you saw the 60, and it kind of looks like it, right? Don't go by the way it looks. So I'm going to redraw it over here. Okay, and so I know that this is 60, this is 12 inches, so this is 12 inches, so this is 12 inches, right? So I know what the base is. I need the height. So by drawing the height, how am I going to figure that out? Oh, good God, no. So 30, 60, 90 triangle. If this is 12, this is 6, this is 6, what's the height? What square root of 3? 6, thank you. 6 square root of 3. Got to know that. Bam, bam, bam. Okay? All right, so I have the base and the height, so that area of the triangle, oh, I forgot my little subscript there, is equal to 1/2 of the base, which is 12, times the height, which is 6 square root of 3. Okay? So what's half of 12? 6, and then 6 times 6 is 36. So the area of the triangle is 36 square root of 3. Now I have my two pieces, right? So all I needed to do was find the area of the sector, find the area of the triangle, and now I have to subtract them, right? So I'm going to do this over here. So the area of my segment is equal to sector minus triangle, that's 24 pi, minus 36 square root of 3. What do the units look like? She's afraid to speak. Help her out. Is she right? Inches squared. You're right. It's inches squared. What do I have to make sure I do here? Parentheses. Written and in Schoology, because it's not a Schoology thing. It's a notation thing. You have to have the parentheses there. Okay? Now, do you think it would be possible for somebody to possibly subtract backwards? Why do you think if you did not have a plan and you just found the things and you knew we were supposed to subtract, that you might subtract backwards? Because the 36 is bigger than the 24, right? Does that matter? No, because remember, this is about 3, right? The square root of 3 has to be between the square root of 4 and the square root of 2. Well, the square root of 4 is 2, so I know that this has to be less than 2, but it's 1 point something kind of close to 2. So this is less than this number. So this makes sense even though these first numbers look weird. So that's why you want a plan so you don't have to overthink it when you get here. You already told yourself what to do. Take what you have, plug it in. There's no overthinking anywhere. As a decimal, remember to use the pi button and all that good kind of stuff, you're going to get 13.044 inches squared. Okay. Questions about that? We good? All right. So let's look at the next one. So once again, it's a segment, so I'm going to have to find the area of the sector and the area of the triangle, and I'm going to subtract them. In order to find the area of the sector, I first have to have the area of the circle. And what would the area of the circle be? It's pi r squared, so it's pi times 4 squared, which is 16 pi. Okay. Then that's going to give me 90 over 360 is equal to the area of the sector over 16 pi. Yes? All right, so then I can knock these out, and I've got area of the sector is equal to 9 times 16 pi over 36. Well, I think I would rather reduce the 9 and the 36 than that right there, so that's going to give me 1 and 4, and then can I reduce it some more? Yes, and the area of my sector is 4 pi. Okay, we good with that? All right. Area of my triangle is 1/2 base times height. Okay, you work on finding that part while I hand out the homework. Okay, so in the interest of time, I know I didn't give you enough time to probably finish the whole thing, but do you know the base of the triangle? Yes. Do you know the height of the triangle? Yes. Okay. Now, you could make your life harder, and you could say, well, all right, I have this, and I know that this is 4, and this is 4. If that's true, what's this? 4 square root of 2. And I could find this height right here. I don't know why you'd want to do that, but you totally could. And if you did, this would be 2 square root of 2, and this would be 2 square root of 2, and you could use this as your base and your height. However, what else could I use as my base and my height? 4 and 4. It's a right triangle. And if you have a right triangle, then your base and your height you can totally use as the legs. Sometimes you don't necessarily have both of them, but I do. They're both 4. So this is just area of the triangle is 1/2 times 4 times 4. So area of the triangle is what? 8. 8. Then what do I do with these things? subtract them. So the area of the segment is equal to 4 pi minus 8. I need my parentheses, meters squared, and that is 4.566 meters squared. So you will have on your homework a triangle that has a different angle than these two. You know how to do them. I'm not going to give you examples of every single one of them. Draw, label, think about what you know how to do. I don't want to see Pythagorean theorem anywhere unless you absolutely have to do it. That is, it just makes me sad that we're still trying to do that on special right triangles. Okay, so go ahead and get that glued in.